Thank you very much, Jeff. I'd like to now invite Allard Castletein to come and deliver his speech.
Dear guests, ladies and gentlemen, after a potentially very transparent and daunting presentation by Professor Sachs, where fossil fuel are the destroyers of the world, I hope you will allow me to give you perhaps a slightly different perspective. I also will attempt to bring to you, as a community of engineers, the fantastic opportunity that actually presents itself in dealing with these phenomenal challenges we're all faced with, and the important role you as engineers actually have in this. But before we go there, I need to show you this disclaimer and to advise you not to make any investment decisions on what I'm about to share with you. You're a smart audience, so I don't need to read it out. Let me start. A couple of words of introduction, because I'm not so vain to think and assume that all of you know Shell with all its key facts and figures. But let me just summarize by stating that we're one of the largest independent oil and gas companies in the world, and that we do consider energy as vital in sustaining daily life, enabling progress around the globe. Shell's purpose is to deliver more energy in ways that are economically attractive and socially and environmentally responsible. We are a company of leading engineers that work on some of the biggest engineering challenges in the world. Last year, the company generated more than $23 billion in profit, and we spent more than $1 billion in research and development, largely on engineering solutions. And now the system deserts me. Engineering solution to get slides moving to the next one would be nice. There we go. You've heard before, and I don't need to elaborate, that more and more people throughout the world are improving their lives thanks to energy. They're traveling, they're working, they're warming their homes, they're cooking their meals, and they currently are plugging their various devices into electric sockets. And global energy demand, therefore, will continue to rise due to the improving living standards and population growth. At the same time, the world's energy supplies are harder to find and more difficult to produce. And the environment and social challenges are increasing ever and ever. So we aim to develop innovative technology solutions to deliver the energy the customers need in that social and environmentally friendly manner. And that approach aims to reduce our environmental impact. It aims to address the challenges. It does not dispute climate change. It does not dispute man-made effects in that context. And we do work closely with partners to address the challenges we're faced with. Now, why do I believe the energy system still needs fossil fuels? If you look at this slide, it tells you that the reality is that the rising energy demand will need to be met by all sources, renewable and fossil. It takes around 30 years, for a new technology solution to reach about 1% of the global energy market. And if you look at the kind of pinkish line that starts in 1970, that's the third from the left, that's the one for biofuels. It shows that it has taken the biofuels market, as similar to the wind energy market, about 30 years to reach that 1% materiality level. So during these 30 years, this new technology still needs to grow 1,000-fold to get from test to that materiality level. And so there, from our perspective, if you do accept that energy is actually an important source for growing prosperity and progress in the world, it does mean that there's no escaping that hydrocarbons will continue to dominate the energy mix in the next decades to come. And our assessment is that by 2050, it will still be 65% of fossil fuels. Now let me again reiterate, we are not saying that there's no role for renewables. To the contrary. Professor Sachs, anything to do with it? So how do we tackle this? At Shell, we believe that responsibly delivering cleaner and more reliable and affordable energy is the best contribution we can make in order to create a more stable world where economies can thrive. We address it by changing our mix. We produce more gas than any other international oil company in the world. And this year, in 2013, we will actually produce more gas than we will produce oil. We also help reduce the impact of the energy needs by being one of the largest and most important biofuels producers in the world. And I'd like to reiterate, this is grown in Brazil. It's water, rain-fed, so not competing for water with local populations. And the land in which the biofuel sugarcane is grown does not compete with land for food. From our operations, we indeed try to deploy carbon capture and storage because we do consider it an important contribution to curtailing greenhouse gases. And we look, of course, at our own energy efficiency in our own operations. Now let me then hopefully show you something which as engineers I hope you would be connected to and would find interesting. Some of the natural gas is the cleanest burning fossil fuel, I should say. When you use natural gas to fuel a power plant, the greenhouse gas emissions compared to coal will see a reduction from something like 50 to 70%. And like I said, if you connect it to a CCS facility, you could reduce the greenhouse gas emissions to 90%. Now, some of the natural gas is found in offshore deposits, far off, for instance, northwest coast of Australia. And a conventional field development with a subsea pipeline and a plant onshore would actually be too costly, hence not economic, or would have a significant environmental impact. So to develop these, Shell is building the first floating facility that not only produces and liquefies gas, but also stores and transfers LNG, all done at sea. And you can look at the dimensions, and you can see that that facility is a factor bigger than the largest aircraft carrier in the US. And I got a short clip here.
That it's to build the world's largest offshore floating facility, which will be a game changer for the energy industry. From bow to stern, Shell's FLNG facility will be 488 metres, longer than 4 football fields, and will weigh around 600,000 tonnes, roughly 6 times as much as the largest aircraft carrier. Shell's FLNG facility will produce gas from offshore fields, liquefying it on board by chilling it to minus 162 degrees Celsius. This shrinks the gas by 600 times, allowing it to be shipped globally. Shell will be deploying this revolutionary technology first 200 kilometres offshore in Australian waters. The facility will be built at a shipyard in Korea and will be used to help open up new natural gas fields at sea that are currently considered too costly or difficult to develop. Its sheer size will help it withstand very high winds and giant waves. It's been designed to withstand the severest cyclones, those of Category 5. As a groundbreaking innovation, this will help meet the world's growing energy demand for the cleanest burning fossil fuel. Shell's decision to make FLNG a reality culminates more than a decade of research and development and 1.6 million man-hours. It builds on the company's extensive knowledge of offshore production, gas liquefaction, LNG shipping and the delivery of major projects.
Hopefully another slide should at some point in time come up. So I've shown you some of the challenges we as an industry are faced with. Now, this meeting is called Grand Challenges, and I suppose this is a nice lead into that we're also faced with huge challenges associated with what we call the energy, water, food challenge, or the stress nexus. Because as you can see from the slide, energy, food, water are very much linked. And if we continue to develop these opportunities, either in food or in water or in energy, along the traditional value chain thinking, then we're missing the opportunity and the stress it actually creates in that other important element, be it water, be it food. So we're actively working with other companies to address new and innovative ways to address these challenges, to come up with more resilient opportunities and outcomes based on the knowledge that we need to collaborate, we need to work together. Now I'm going to round off by showing you that it's not only engineering solutions that we should be looking for, and there's other opportunities that actually are just as powerful in the future world.
At the Nimmer oil fields in Oman, thousands of barrels of oil are produced every day. But only a tenth of the liquid brought to the surface is actually oil. The rest is water, which must be cleaned and disposed of. In the past, Petroleum Development Oman has pumped the water back underground, but this is costly and uses energy. A new approach uses reed beds to purify the water before it evaporates naturally beneath the desert sun. Using the new technique, most of the crude oil is first separated from the water. Traces of oil, however, remain in the water. Pulled only by gravity, the oily water then flows downhill through about 1.5 kilometers of reeds. As it passes through, the oil sticks to the reeds and is eaten by natural microbes living on the plant. By the time it reaches the bottom of the fields, the water is 99.5% pure and can be left to evaporate safely in the sun.
Die 4 Schilfkläranlagenstufen haben alles, was von der Ölproduktion noch übrig ist, an Öl entfernt. Auch die gelösten und im Wasser noch verbliebenen organischen Stoffe sind abgebaut worden durch das Schilf.
After a successful trial, the plant has been expanded to more than double its size. Engineers also hope that the process can soon be used elsewhere.
Die Vorteile liegen natürlich klar darin, dass so eine Anlage den Energieverbrauch für die Abwasserreinigung fast auf 0 runterfährt.
So to summarize, to meet the energy demand, we will need to continue to produce energy from all sources, fossil fuels included. Sustainable development is at the heart and at the core of everything we do. And innovation is in our DNA, and we need to collaborate to address these grand challenges of the future. Thank you very much.
Thank you very much.